today taking our shapes and dilating them. So at the very top, we have a couple definitions that we're going to start with, and then we'll do some example problems. Okay, so right at the top there, dilations. Okay, 18th, like I said, 218. Okay, so a dilation takes a figure and it either enlarges your figure or it shrinks or reduces your figure. So it either makes it bigger or it makes it really, really, really small. So a dilation can either enlarge, right, make bigger, or reduce one, make it smaller. Okay. Okay. All right, thank you. What test are you taking? Okay. All right, when a dilation has occurred, the image is similar to the pre-image, which means it's the same size but a different shape. Wrong way. I just said the wrong thing. Same shape but a different size. My bad. So similar means same shape, different size. What's the word that we use if it is the same size and the same shape? Congruent. So if everything's exactly the same, it's congruent. When it's the same shape, a different size, it's called similar. Now, when we go to write that something is similar, just like with everything else we've done, we don't really write the word congruent. We don't write the word similar. We have a little symbol that we're going to use to show something is similar. So for example, I'm going to say triangle ABC. So this was what our warm-up was, right? We had triangle ABC in our warm-up. If I wanted to take that triangle and make it similar to another triangle, so if I make it bigger or smaller, the symbol for similar is just the little squiggle. So if you think about congruent, it's the squiggle with the equal signs. Similar is just the squiggle at the top and nothing else. And then when I name my next triangle, so you start with the pre-image, right? That's your beginning shape. And then once I make it bigger or I make it smaller, it's called the image. And to show that it's a transformation of some kind, when I rewrite the letters to the triangle, I put the little primes next to them. And so hopefully you remember when we did transformations, right? We had those little tick marks to show that it was a new triangle. We're doing the same thing with our dilations. So in order to dilate, make a picture bigger or smaller, you need two different things. One thing is called the scale factor. One thing is called the center of dilation. Now, the scale factor just tells you how big or how small you're making your new shape, right? Just telling you how big or how small something is. I'm going to give you the real definition, but it just essentially means, are you making your picture bigger or making picture smaller? So the real definition is the ratio. What's a ratio? It's another word for ratio. Yeah, a decimal or a fraction. Yep. So the ratio of any two corresponding lengths in two similar figures. The ratio of any two corresponding lengths in two similar figures. Again, just means how big or how small are you making your picture. That's all that means. Okay, so when we dilate, we tell ourselves, okay, how big or how small do we make it? And the other part we need is the center of the dilation. It's exactly what it sounds like. It means where are you centering your graph? Around what particular point? Okay, so it's just a fixed point, which means it doesn't move. A fixed point around which a dilation occurs. around which a dilation occurs. So we've got our point where our dilation essentially is centered. And then we've got scale factor just means how big or how small do we make it. When we talk about the scale factor, we use the letter K. And when we talk about the center of dilation where it's around, we use a coordinate because it's a point on the graph. And every time we do a dilation, we're going to use the very center of a graph, the origin, which is just 0, 0. So that's never going to change for us. The only thing that's going to change is our scale factor. So our center of dilation is always going to be 0, 0 at the origin, right at the center of our graph. Okay? All right, so there's two things you can do. We talked about you can enlarge your dilation, right? Make it bigger, or you can reduce it, make it smaller. If your scale factor is bigger than 1, so any number bigger than 1, 1.5, 2, 3, 4, 5, whatever. If it's bigger than 1, your graph's going to get bigger. If your scale factor is between 0 and 1, that means if it's a fraction, what do you think is going to happen to your graph? It's going to get smaller. So if it's a whole number that's bigger than 1, your graph's going to get bigger. If it's a fraction that's between 0 and 1, your graph's going to get smaller. That's it. All you have to do, right? And so you should be able to just look at it and say, hey, I can tell my graph's going to get bigger or my graph's going to get smaller. So let's do an example here. It says, draw a dilation of the figure using the given scale factor. The center of dilation is at the origin. So right at the center at 0, 0. This is where my graph is going to be centered. Again, that's not going to change for us. And then right up top, the K value is your scale factor. So my K value is 2. Is my graph going to get bigger or is my graph going to get smaller? It's going to get bigger. So I'm going to put enlarge. Or you can put gets bigger, whatever you want. So when I redo my graph, it should just get bigger. Okay? Now, here's all you have to do. We're going to start by writing the coordinates of each point. Okay? So first point, point A. What are the coordinates of point A? 1, 1. I know they're really light. I know it's hard to see. I apologize. Back's a little easier to see. What about coordinate B? 2, -1, right? You go over 2, you go down 1. Okay, and then coordinate C. Over here. What's this one? -2, 0, right? Because we're going to the left. Okay, so my scale factor is 2. All you have to do, it's super easy, is you always multiply by the scale factor. So what I'm going to do for all 3 of these points is I'm going to multiply them by 2. Multiply by 2, multiply by 2, multiply by 2. We're going to write the coordinates first, and we're going to graph it second. Okay, now when you multiply both the x and the y by the scale factor, both parts of it. You want to do, because if you just do one part, then your graph is only going to grow halfway. So my first point was 1, 1. If I multiply both of these coordinates by 2, what do you get? 2, 2, right? So my new coordinate, now when I write it, I'm going to put a tick mark next to it to show it's a transformation. It becomes 2, 2. Good. Let's graph that actually. So 1, 2, 1, 2. And again, when you graph it, make sure you put the little tick mark next to it to show that it's a new point. All right, point B prime. I'm going to multiply both of these by 2. So 2 times 2 gives me 4. So I multiplied both the first number by 2 and the second number by 2. I'm sorry? Yes. Good luck on your test. So I do the same thing for B, right? 2 times 2 gives me 4. -1 times 2 gives me What kind of 2? Negative 2. So that point is at positive 4, negative 2. So let's graph that. That means you go to the right 4 and down 2. So here's B prime. And last one, C prime, I do the same thing. Multiply both of them by 2. So negative 2 times 2 gives me negative 4. 0 times 2 gives me 0. So my coordinates for C prime are negative 4, 0. So let's graph that. That means you go to the left 4. And then 0 means you don't go up or down. Stay right where you are. That's C prime. So if I connect those 3 points to the best of my ability, it's not going to be perfect, but ta! Same picture, just boom, got bigger, right? So it's the same shape, just a different size. And that's it. That's all a dilation is. Is that not the easiest thing ever? So all you have to do is multiply by the scale factor. Multiply by the scale factor. And we're going to do that every single time. We're always going to multiply by the scale factor, no matter what. All right, so let's try number 2. What's different about number 2? My K is 1/2. What does that mean is going to happen to my picture? It's going to get smaller, okay? So I'm going to write next to it, either you can put smaller or reduced, doesn't matter. Okay, so we're going to do the same thing we just did. We're going to write the coordinates first, then we'll multiply second. And I know these are like super hard to see, so I'm actually just going to give you these coordinates because they did not print very nicely. Okay, so my first coordinate, point A, is at 4, 4. So to the right 4, up 4. Point B is at positive 4, and then I go up 8. So 4, 8. Point C is at 6, 4. And then point D is at 6, 6. So those are my original points. Okay, now we're going to do the exact same thing. I'm going to multiply by the scale factor. So that means I'm going to take these coordinates and I'm going to multiply all of them by 1/2. Now, when you multiply by 1/2, what's that the same thing as doing? Dividing by 2. So you have a choice. You can actually put, if you want, like times 1/2, or this is the same thing as dividing by 2. So either one is fine. Whichever way, like, your brain can function a little better. But I think it's easier if you do the division personally. Okay. So we're going to do the same thing. I'm going to write the new coordinates, and then we're going to graph them. All right, so I'm going to do it by doing dividing by 2 because it makes it a little easier, and I'm going to put the new coordinate right next to it. All right, so if I divide 4 by 2, you get 2. And again, I do the same thing. 4 divided by 2, I get 2. So my new A coordinate is going to be 2, 2. I'm just dividing them both by 2. Yes, it will be prime when I go to graph it. I just don't have enough space. What will my B prime be? 2, 4. Good. So this is my, I'll go like this, A prime. Just to remind myself. All right, what will my C prime be? 3, 2. And then what will my D prime be? 3, 3. Good. And there's me, your new coordinates. So to the best of your ability, try to sketch it. I know it's super hard to see, but 1, 2, 1, 2. This is A prime. 2, 4 is B prime. 3, 2 is C prime. And 3, 3 is D prime. So it's the same thing. It's just way smaller. And again, it's centered around this point right here, 0, 0. So because it's getting smaller, it's going to get closer and closer to 0, 0. As it gets bigger, it'll get further and further away from it. So as you look at your picture there, you should say, okay, does that look like the same shape? It does, just smaller, and you're finished. That's it. Questions so far? Not bad, right? There's multiplying by the scale factor every time. All right, flip it over. All right, I'm going to skip 3 and 4 for the moment because you guys are going to do that one without me. I'm going to do 5, 8, and 9 with you, and then I'm going to let you kind of finish the back side, and we'll check it at the end. Okay. So number 3 and number 4 are exactly the same. It's just a little bit more practice with the dilations. In number 3, is your graph going to get bigger or smaller? Bigger. It's going to get larger. In number 4, is your graph going to get bigger or smaller? Smaller. It's the exact same thing. Don't let the fact that it's a line scare you. It's just one last point you have to do. Okay? All right, now let's take a look at number 5. Number 5, 6, and 7 says, given the point and its image, determine the scale factor. So this time, I'm giving you your starting point, and I'm giving you your ending point. And you have to tell me what's the scale factor. What are you multiplying by to get to your new number over here? Okay? So here's your starting one. This is called your pre-image, right? Because it's just the A by itself. The new point is called your image, right, with the little prime next to it. Okay, so we're just going to look at either the x's or the y's. It doesn't matter which one you look at. If you're looking from your, let's look at our x's, 3 to 4.5. Are we getting bigger or are we getting smaller? We're getting bigger. So your number, your scale factor should be greater than 1. Now, you might be able to just look at it and tell, how do you get from 3 to 4.5? What do you have to multiply by? 1.5, right? So one way to do it is just by looking and saying, hey, 3 times 1.5 gives me 4.5. That's your scale factor, because you multiplied by 1.5. That is one way to do it. But sometimes when you look at the numbers, they are not so easy. Another way you can do it is take the image and divide it by the pre-image. Image divided by the pre-image. So you would take 4.5 and divide it by 3. And take a wild guess what number comes out when you do 4.5 divided by 3. You get 1.5 again. Yeah. So your scale factor is 1.5. And when we write it as K equals, because K means scale factor. Okay, so either, like I said, either you can just look at the numbers and kind of do mental math on your own, or if the numbers are too hard, you can just divide the two numbers. That's all you have to do. Image is always going to be on the top. Yes, good question. Always put the image on top. Doesn't matter if you do your x's or your y's, you should get the same number. Yes? Yeah. So even if you did your y's, here are your y values, right? 9 and 6. If I divide 9 by 6, I'm still going to get 1.5. Thank you. So either one's fine. Let's take a look at number 6. Be careful with this one. What's different about this one? I flipped them. Yeah, so be really careful. This one is your pre-image because it's all by itself. It doesn't have a tick mark. This one on the left is your image. Okay, now you can either look at your x's or your y's. Let's look at the y's this time. Okay, if you're going from the pre-image to the image, what do you have to do to get from 3 to 6? Multiply it times 2. That means your scale factor is 2. Or we can divide. We always do remember image over pre-image. So 6 divided by 3 gives you what? Gives you 2 again. So your scale factor is 2. Nice and simple. Okay, last one, number 7. Same thing. Which one is your image? The first one or the second one? First one is your image. Sorry, pre-image. Right, pre because there's no tick mark next to it. The other one is your image. Again, we can either look at the x's or the y's. It doesn't matter. First one is your pre-image. Second one is your image. Because it doesn't have the tick mark. If it's got this little tick mark here, the prime symbol, that means it's your image. Okay, now this time doesn't matter again which one you look at. I'm going to look at the x's, so I don't have to deal with the decimal. What happens this time? You're getting smaller. You're going from 2 to 1. What are you doing? You're dividing by 2, right, to get from here to here. Now, when we do the scale factor, though, we're going to have to write it as a fraction. Dividing by 2 is the same as multiplying by what? 1 over 2. Very good. Or, again, you could just do image over pre-image, which is 1 over 2. There's your scale factor. So dividing by 2 is the same as multiplying by 1/2. Good. All right, number 8. It says, determine the scale factor from the graph. Now this time it's the same thing, but instead of me giving it to you as coordinates, I'm giving it to you as a graph. Now, you only need to pick one of the points. You don't need to do it for all 3. So let's just pick one point. Which one of those is your pre-image? The smaller one or the bigger one? The bigger one. How do you know that? No ticks. Okay, so the bigger one is my pre-image. All right, so let's pick just one point from the pre-image. We can pick D, E, or C. Which one do you want to pick? E? Okay. What are the coordinates of point E? -3, -3. So I go to the right 3, I go down 3. Now we're going to go to our image, which is over here. This one's my image. And I'm going to write the coordinates of E prime. I need to keep the same point. What are the coordinates of E prime? 1, -1. Good. You go to the right 1. You go down 1. Okay, to find the scale factor, we do the image divided by the pre-image. So we would do what divided by what? 1 over 3. Good. Or you could do -1 over -3. Do I have to do anything else? Can I reduce that in any way? Nope. And this tells me, did your graph get bigger or smaller? It got smaller, and that's exactly what happened in my picture. There it is. It got smaller. So my scale factor is 1/3. Make sure you always put a K with it to show it's your scale factor. Okay, and I'm not going to actually do 9, 10, 11 because I think you can do those on your own. So we got a couple minutes right now. We got about 10 more minutes. I would like you to finish up 3, 4, 9, 10, and 11. Okay, if you haven't already. And then we're going to check those answers probably realistically tomorrow as soon as we get in. Okay, so you're going to finish 3, 4, 9, 10, and 11. You're either graphing your pre-image and image, or you're just telling me what the scale factor is. Okay, so take a moment if you have not finished those ones on the back to finish them now. And then you're done for the day. That's all you have to do today. We're going to do some practice with it a little bit more tomorrow.